Okay, so last time we talked about our Yum's Bakery and we developed our constraints for that based on our problem. And then we wrote the objective function. So the next thing that we need to do is then graph and then find our test vertices, whatever those corners of that solution region are going to be. Now you can see here I labeled our graph. In order to do that, I did the cover-up method to figure out how far I needed to go out for x and y. And in this case, I decided I needed to count by fives to get enough, or to get big enough to get all the stuff I needed to on the graph. So really what I want to do is start with the 5x plus 2y is less than or equal to 180 inequality. So I'm going to stick with green to graph that. And so again, cover-up method, if I do 180 divided by 5, I get 36. And so on the x-axis, I want to graph 36. Now this is going to be a little bit tricky. So 35 is right here. So I want to be just a tad past that. Okay. And then if I do 180 divided by 2, I get 90. So that one is going to be a little easier. Okay. Now, when you are doing these, it's extremely important that it's as accurate as possible. So you want a nice straight line because where they intersect is going to be important. So here we go. Okay. All right. Now it is, let's see, less than or equal to. So if I put 0, 0, that would be a true statement in there. So I would be shading this in this way. Okay. Now let's do the other one. Our red inequality says 3x plus 3y is less than or equal to 135. This is for flour, our constraint for flour. Now, if we do 135 divided by 3, we get 45. So it'll be 45 for our x-intercept and our y-intercept. So that is a little easier to graph here as well. Okay, and then once again, okay. All right, now this one is less than or equal to as well. So this is going to be shaded down. Okay, and then what we're really looking at then is this area kind of right in here. So I want to shade that. Before I do that, I think I'm going to get rid of my arrows there and need to use a little bit smaller one. Okay, and then we are going to shade this. Okay, so let's see here. Okay, this region right in here. Okay, so this is my solution region. Any point in here is going to work for the Yum's Bakery. But now the key thing here is we want to maximize profit. Remember back in here it says how many batches at the top. How many batches of each bread should the bakery make to maximize profits? Well, anything in that sort of aqua color will work, but we said last time that the maximum or the minimum is going to occur at the vertices. So the best option for you to either maximize or minimize has to occur at one of these corners. Okay, so that's the nice thing, is I don't have to test all the points that are in here. I just need to test the corners. So that would be this point right here, this point right here, that one right there, and then this one. Okay, so here we go. We're going to write our test vertices. So our test vertices are, so this one right here is 0, 0. Okay, let's go up here. That would be 0, 45. Okay. Let's do this one next. So that is, remember that was 36, 0. And then this point right here, that's 30, 15 maybe. So now you'll notice my graph is a tad off, and I'm not 100% sure that that's 30, 15. So then what you want to do to confirm is we can use the previous. So if we look at these two right here, what I want to do is find out where those two lines cross. That would be that point that I have the arrow there pointing to. So how do we do that? We can use elimination here. So if I use elimination, change those to equal signs and solve for where they intersect, I will end up getting the point 30, 15. So that is how you can confirm if you're not 100% sure. The better your graph is, the easier it's going to be to tell. And mine is just a tad off, so I did confirm that is 30, 15. Okay, so those are my test vertices, and I just have to figure out which one of these is going to be the best. Now, sometimes it'll be kind of obvious in here, and other times not as obvious. It really depends on this profit or cost or whatever equation you're talking about, your objective function. It really depends on what that looks like. Okay, so if I put in, I'm going to just test these and figure out what I get. So if I start with this one, I'm going to go 40 times 0 plus 30 times 0. And that is going to give me, obviously, if I don't sell any batches of either of the breads, I'm going to get a profit of $0. So that should make some sense. Next, what if I sell 0 of bread A and 45 of bread B? So 30, so what is that? 135, 1350? Let's confirm. Yeah. $1,350 profit if they sell 45 of just bread B. Okay. Okay, if we sell 36 of bread A, this would give us 1,800, I think, if I remember. Oh no, 1,440. Okay, so that's a little better, but a little bit more than the other one. Now, what if we do 30? It'll give us 1,200. Okay, so that'd be 1,200 and then 450. So that would give us $1,650 if we said sold 30 of bread A and 15 of bread B. Okay, so now which one is the best? Okay, going back up here, it says how many batches of each bread should the bakery make to maximize profits? So in this case, we're trying to maximize profits. So this one is going to be my best option. So when we write our solution, though, we're going to write it out in words. So let's do that. Yum's Bakery should make 30 batches of bread A and 15 batches of bread B. To maximize profits. Okay. This will give them the most bang for their buck. Okay. And that's really what you're going to be doing in your assignment, is just kind of going through these last parts. How do we graph, again, reviewing that. How do we test an objective function and then determine which one is the best. Remember, it could be maximizing or it could be minimizing. In this case, if they said to minimize, obviously the 0, 0 would be the lowest. So it depends on what you're asking for. Okay, this is profit, so maximizing makes sense. All right, hope that makes